All right, welcome back. Sorry for the delay, guys. We are going to cover in this Creative TD video how to do your own custom lighting model using surface shaders. And this is where the real power of using surface shaders comes into play, because if you're to do some of this stuff with standard CG type shaders, there's a lot more code. It's not necessarily more difficult, it's just a lot more code, so there's a lot more management of your variables, of your components that you're bringing in, like normals and vertices, and how you're working with all that stuff. So Unity is really kind of boiled down to just what you need inside of the surface shader, so that you can actually achieve some really nice advanced shader effects like you see in most console games nowadays. So let's get started. And what I'm going to do first is I'm going to leave this here because this represents all the tutorial videos, all the techniques that we've done so far to date, and using just the built-in lighting models. All right, so what I want to do is I'm just going to make another sphere here. And this guy is just going to be placed over here. And I'm just going to remove the collider. I don't need it. All right. And I'm going to make a new material. So I'm going to create a new material, and this is going to be a custom lighting matte. And what I need is a new shader. So I'm going to create a new shader, and this is going to be called our custom diffuse. Because in this particular custom lighting model, what we're going to do is just a really simple Lambert or diffuse lighting for our material. So it'll be really easy to understand. It'll go pretty quickly, but we are going to write the shader from scratch again, just so we get in the habit of practice. So let's get started with that. Let's wait for MonoDevelop to open up here. Let's see, where did you go? There we go. Oh, there we go. Okay, we are now back in business. All right, so what we need to do is go to our custom diffuse, and I'm just gonna blow away all the default code in there. I mean, you can always obviously start from that, but I just want to actually start it from scratch. So I'm going to first declare a shader function, right? And I'm going to give it a name. So this is going to be placed into my CTD folder, into its own subfolder, and I'm going to call this my custom diffuse, and then put brackets around it. So our shader will be, all of our shader code will be contained inside of here. So I'm just going to have one property. So I'm going to say properties, and this is another function, and we are going to just do a texture. So I'm going to say main text, make some parentheses, and this is going to be a texture, or a diffuse texture. Excuse me. Diffuse texture, and this is going to be of type 2D, and we're going to give it a default value of white. All right, and that completes that. So then what we want to do again, we want to start the subshader. All right, so this is where all of our CG code will go, and all the surface shader code will go. Okay, so before I do that, I just want to give this shader a rendering type. Okay, so we're just going to use opaque for this because we don't need any sort of transparency or render to texture type stuff. So I'm going to say render type. Oops, render type is equal to opaque, and that has to be a string as well. All right, and now we can actually start the CG program. So CG program. All right, and then always follow that up with NCG. It's just a good habit to get into, always putting the opening and closing CG comments there. That way you won't have to spend hours trying to debug it and then just realize that you forgot to put NCG. So always good to open and close it. All right, and then what we want to do is we want to declare this. We want to declare our surface type, okay? And that will start the custom lighting model. So we want to say pragma surface surf, and we're going to give it our own name. So basically I'm going to call this my custom diffuse. So custom diffuse right there is the actual name of our lighting model that we are going to create. And these two comments here tell Unity that's going to be a surface shader. All right, So it's going to look for this when it tries to render this to the screen instead of one of the default built-in lighting models. Alright, so let's go and start writing our lighting model. So half 4, so we're going to put it into a half 4, or this is going to return a half 4. And I'm going to have to always start the name of the custom lighting model with lighting. That term right there, that word, this keyword right here, has to be put in front of our custom name, so custom diffuse. So it's very important right there. So you need lighting custom diffuse, right, in our case. So just put lighting in front of whatever custom name you put in for your pragma statement. Okay, and then we just need to give it the arguments. So now we need surface output, so we can actually output the value and put that into a variable. And then we need the light direction. So we're going to say light dir. Now this is a built-in value that Unity provides us. One of the reasons, like I was mentioning before, they basically give us all this stuff, whereas if we were writing our own CG code, we'd have to do a lot more hand writing of code to get all the lights in the scene. Alright, and then we just want to put in an attenuation value for those lights. Alright, so then we are now ready to get our lighting going, and if you remember from one of the previous videos, we are actually going to just use the dot product to calculate the normal to the light direction. Right, and that will give us a nice gradient over the model from 1 to 0, or -1, if you will. And actually, in this case, the way we're going to do it is it will return a negative value. So we'll say n.l equals dot. We're going to say we're going to bring in the normal, so s right here. All right, dot normal dotted with the light direction, like that. And bam! Right away, now we have the -1 to 1 value, right? And if you wanted to put it back into range, 0 to 1, we just saturate it like that. Oops, like that. So now we have a nice even value. All right. So what I'm going to do next is I'm just going to declare a value that I'm going to return all the colors into from this n.l function, or this dot product function. Okay. So I'm going to say half for C, all right, because we need to return a half for C, so this is going to be our return variable. Okay, so I'm going to say C.RGB equals S.albedo, because that's the built-in variable for surface shader, all right, for the color, if you will. We're going to say light color. This is how you access the light color from the lights, RGB, and we're going to multiply that by our n.l multiplied by our attenuation, so the actual effect will fade out as the light gets further away from our object, and we multiply that by 2. And then the alpha is just equal to nothing really right now. And then we return the C value. Right? So now what we've done is we've actually built up a simple diffuse using the dot product. We've declared our return variable that we want to actually return when this function is called. All right? We've built our actual color based off of the light's color and the actual distance away from the light. It is right here. And we're just filling the alpha with the default value right now. And then we are returning that to when we actually use that lighting, when Unity uses this lighting model. So at this point, everything else is pretty much standard stuff, right? So we just want to struct right here, and we're going to call this our input. And we need the semicolon at the end of there. And all we need are the UVs for our texture up here. So all we need are those UVs. So what we're going to do is just say UV main text. Yeah. All right, so now we have our UVs. And then we need to pass that texture to the CG shader. So main text. So now I actually have access to the pixel values inside of, so I have the UVs now, and then I have the access to the actual pixel values in that texture. Alright, so now I'm just going to say void surf. This will call our lighting function up there. We're going to say input in. So I'm going to bring in all my input values, and in this case all I have is my UVs for my texture, or for my model. And then I'm going to say in out surface output O. These are just values. These variable names are just kind of standard values that when I learned to write surface shaders using the manual that Unity provided. So I've just kind of stuck with these. You can have any name you want for these guys, really, right? Because these are just your identifiers for how you actually want to use them inside of this function here. All right, so the in-out surface output is allowing us to modify our custom lighting model with whatever operations we do inside of this surf function right here. All right, so in this case, all we want to do is modify that albedo so that we can add on our texture. So we say text2D, and we feed it the texture, main text. We say in.uv main text, and then RGB, just so we get the float 3 or half 3 values. All right, and that should do it. So then, again, as a fallback, or as a kind of a standard, you should always put in some sort of fallback. That way your shader always works at least. And say diffuse. And that is how you write a custom lighting model. So let's save this and see how many errors we can actually get inside of Unity. All right, so we got a few here, so let's take a look. Let's see, there's a parse error at line 13. So let's see what that is. Well, it's not tag, it's tags, first off. So let's try that. All right, so let's go to 23 now. Shader, surf shader internal function assignment, none. So let's go to line 23 here. Let's see what we did wrong. It looks right. Albedo looks right. That all looks right. So let's see, let's just make sure all this stuff is working okay. Let's get rid of the saturate for a second just to make sure so we're not overcomplicating our shader. Oh, that is the other problem. There it was. I see it now. So I actually just declared the C as a half. This actually needs to be a half 4 because we're filling it with color. So let's save that. All right, and it says oh, and I spelled albedo wrong. So there you go. That is how you debug a shader. Pretty easy. You just need to look at the first error. That is usually the first one that you need to look for. So let's say we'll find compatible overload for the error, and the error is actually in the variable in here. So let's see what I did. So it's in, and I actually made it in. So let's do that. So there we go, and we have an ambiguous overloaded function here. So let's see what I did. Let's just make sure all of our variable names are the same. And this is also another problem right here. This has to be a float too, because we're bringing in X and Y for the UVs. So let's save that. And one more. And we have to make sure we spell saturate right. Sorry everybody, it's early here in Seattle. And oddly enough, it is raining. There we go. We did it. So now we have our custom lighting model. It's all compiled. So let's go to our custom lighting mat, and let's do the drop down here. Let's go to CTD and get custom diffuse. And let's see, let's go into textures, and let's put on our texture like that, and then let's just give this to that. There you go. That is a custom lighting model right there. Now you notice obviously there's not much difference, but In the next few videos, we're going to start to dive into how we can start to create some really advanced lighting effects using textures, and I'm going to get into the BRDF stuff, as most of you really want to see, and we're going to get into how to do the diffuse wraps, just like Team Fortress 2, stuff like that. It's all pretty basic stuff, but it's just knowing how to manipulate those 2D images to wrap them around the actual object. That is the key. Anyways, I hope you enjoyed this video and learned how to create a custom lighting model and also how to debug a shader. And I look forward to getting on to the next videos. Thanks so much. Bye.